Hey guys, good morning. It's me again, the Mr. Sniper. So today I'm trying to show the student how to do making a graph for rational functions. So here's the step that student needs to follow through. So we'll talk about that. And first thing is that once you get the rational function, first thing that you want to do is to factor it. And then you want to find the xy intercept. And then once you get the xy intercept, you want to get the vertical asymptote, the VA. And then step 4, you want to get the horizontal asymptote. If there's no horizontal asymptote exists, you want to find the slant asymptote. And for number 5, step 5 is just make the whole graph. So here's the one. So for the rational function, we got the trinomial on the top and another trinomial down the bottom. So the first thing that you want to do is to factor it. You try to factor it mentally. So here's what we got. So it's 2x minus 1 times x plus 4, and then denominator is x minus 1, x plus 2. And for those students having a hard time with the factoring, we actually talk about that in Algebra 2, Algebra 1, with the smiley face or the cross method. So after you factor it, you want to find the y-intercept. So in order to get the y-intercept, you want to set x equal to 0. So once you plug in all the zeros there, so you just solve for y, and then you end up with 2. So 0, 2. And then for the x-intercept, so you want to do something that's kind of like opposite, so set y equals 0. Now, the only thing that we can set equal to 0 is just the numerator, because the denominator, if you set equal to 0, then that would be undefined. And also, denominator, that's just for finding the vertical asymptote. We'll talk about that for the next step. So set the numerator equal to 0, and then we factor it, and then we solve for x. So we got 1/2 and -4. So once we get the xy intercept, so for the next step, we can just get the vertical asymptotes. So for the vertical asymptotes, basically just finding the restrictions of the rational functions. So again, if the denominator is zeros, the entire rational function would be undefined. So we set the denominator equal to 0. So we got 1 and x equals -2. For the end behavior, there's no need to test the end behavior or the behavior near the vertical asymptote. So this one is just like a extra step that you probably consider doing for checking the work to find out whether that y goes to -infinity or +infinity. So this one is unnecessary. So we can skip all this. And also you can test the sign to find out whether it's down below the x-axis or right above the x-axis. Again, all this step here, they're unnecessary. And also testing the sign change with that boundary. So the last thing is that before we sketch the graph, we want to find the horizontal asymptote. And we talked about that yesterday. We do have 3 different scenarios finding the horizontal asymptote. So the first case is that the degree on the top is less than the degree down the bottom. And the second case is that it's the same degree top and the bottom. So we just take out the leading coefficient for the horizontal asymptote. And then the last case is that there's no horizontal asymptote, which is that degree on the top is greater than the degree down the bottom, and which means that we have to find the slant asymptote. So there's going to be another video posted up probably by tomorrow with finding the slant asymptote. But this one is actually case 2. As you can see, that it's the same degree top and the bottom. So what we have to do, we just need to take out that 2/1, and that would be the horizontal asymptote. And you may want to take out that the end behavior, or the one that with the greatest power. So once you factored it, you end up with something like this. And as you can see, that x goes to infinity, so that denominator goes to infinity, and then 7/infinity turns out to be a very small number. It's almost getting close to 0. And then 4/infinity squared, so that would be even smaller, so it's getting close to 0 even faster. So basically we can just reduce all the one that, with the circles, they'll all cancel out. And then x²/x², which means that we can reduce. So eventually we got 2 remain. So once you plot the points, so here's what we got. So as you can see, that x goes to -infinity, y goes to the horizontal asymptotes, and then x goes to infinity, y also goes to the same horizontal asymptote. So for the slant asymptote, when do we find the slant asymptote? And the way to find it is by using the synthetic division or the long division. And remember that in order to use the synthetic division, that means the divisor must be a linear binomial. So here's one of the examples for finding the slant asymptote. So again, finding the VA by setting the denominator equal to 0. So we got x equals 1, slant asymptote. We can use the long division or the synthetic division. So once you divide it, so we end up with x plus 3, and then plus 3 over x minus 1. And one thing, that remainder with the divisor, we can just disregard them, because that it has nothing to do with the slant asymptote. One thing is that x goes to infinity, so the entire rational, so this one is going all the way to 0. So the only thing that we left with the slant asymptote is x plus 3. Thank you for watching the video.